You know that feeling when you ask an AI for something really specific, maybe a task with multiple steps, and it doesn't quite get it.
Oh, absolutely.
It's like it heard some of your words, but somehow missed the whole picture,
Yeah.
leaving you to clean up the digital mess.
Yep. Frustrating.
Today, we're taking a deep dive into a fascinating new approach that could genuinely change all that, making our AI interactions far more precise and, well, satisfying. Okay, let's unpack this a bit. Language models are incredible, no doubt about it, but getting them to faithfully follow truly complex, nuanced instructions, that remains a significant challenge.
It really does.
Current methods, they often rely on these broad, kind of fixed criteria during their training, things like helpfulness or harmfulness.
Right. Very high-level concepts.
And these can fall short. Worse, they can even lead to what researchers cleverly call reward hacking,
Hmm.
where the AI finds these clever shortcuts to appear successful without actually doing what you asked.
Precisely. And these existing reinforcement learning techniques, like traditional RLHF, reinforcement learning from human feedback, they struggle particularly with what we might label non-verifiable tasks.
Unverifiable.
Yeah, these aren't simple true or false situations, right? They're often multifaceted goals, maybe requiring some subjective judgment.
Okay.
So to truly serve users and their, multitude of needs, these models desperately need a more flexible, more granular way to understand and respond. The current broad strokes just aren't cutting it.
And that, listeners, is precisely the fundamental challenge that this idea, reinforcement learning from checklist feedback, or RLCF, was designed to tackle.
Right.
It's a new approach that tackles this problem head on. And interestingly, it's not by trying to redefine good broadly, but by making it incredibly specific.
Exactly. Tailored.
So our mission for this deep dive is to explore how this innovative method uses these dynamic instruction-specific checklists to finally help language models truly understand and execute our requests. We'll look at why it seems to be proving more effective than other methods, and most importantly, what this all means for you, the person interacting with these powerful tools every single day. You've probably used LLMs for all sorts of things. Sometimes they're spot on, just delivering exactly what you needed. It's brilliant when that happens.
Yeah, it feels like magic sometimes.
But for those richer multi-step instructions, the ones that are more than just a single command, you might notice they sometimes miss the mark.
Definitely.
You ask for 3 specific things and it gives you 2, or maybe it gets the tone wrong, or misses a crucial detail. It's like a brilliant but slightly distracted intern.
Huh, that's a good analogy. And the core issue, as you rightly point out, is really in how these models are typically trained after the initial pre-training.
Okay.
After that initial fine-tuning, they often undergo reinforcement learning, usually with human feedback. In this stage, they get rewarded for generating good responses and penalized for bad ones.
Standard RLHF, basically.
Right. But the problem is good and bad are often defined by these very fixed, high-level criteria like basic helpfulness or, critically avoiding harm, which are important, but
Too generic.
exactly, they're too generic for complex instructions. And what's fascinating here is how these broad, sort of undifferentiated criteria can lead models to optimize for the reward signal itself rather than genuinely fulfilling the user's instruction.
So gaming the system.
Pretty much. This often results in reward hacking. Imagine telling a model to be helpful, and instead of actually helping you write your essay or giving you that list you asked for, it generates this incredibly well-written, grammatically perfect essay about the history of helpfulness.
Oh, wow. Okay.
It gets a high helpfulness score, technically, but completely misses your specific intent. It reminds me of that classic internet meme, where someone asks an AI for a picture of a cat holding a pizza,
Vaguely.
and it delivers a cat-shaped pizza, literally holding itself.
Oh, right. I remember that.
Yeah. It technically contains cat and pizza, but completely misses the spirit of the request.
That's such a vivid example. It really highlights that gap between what we say and what the AI understands. So this new paper from Vijay Viswanathan and colleagues at Carnegie Mellon and Apple suggests a brilliantly intuitive solution: checklists.
Checklists. Simple, right?
It sounds almost deceptively simple. My first thought was, can something so seemingly basic really tackle such complex AI challenges? Or are we just, shifting the complexity somewhere else?
That's an excellent question, and it's sort of where the elegance lies. RLCF proposes moving beyond those vague notions of good. Instead, for each user instruction, the system generates a flexible, instruction-specific checklist,
Okay.
a list of precise requirements the response must satisfy.
Oh, okay.
This makes the feedback much more granular, much more targeted, and directly tied to the user's explicit request. It makes the whole evaluation process far less subjective.
Let's take a real example from the paper to make this concrete.
Duh.
If you prompted an LLM with, say, list of Airbnb in Singapore for 2 packs less than 5,000 pesos per night.
Right. A typical request.
A standard reward model might just give it a general score for helpfulness, maybe accuracy. But with RLCF, the system would generate a specific checklist, something like this.
Okay.
1. Does the text provide a list of Airbnbs in Singapore? Wait, 100, 100.
Crucial.
2. Does each listing accommodate 2 people?
Right.
100, 100.
Also crucial.
3. Does the text provide useful tips if real-time listings are not available? Wait, 75, 100.
Interesting. So optional but helpful.
Exactly. That level of precision, identifying these distinct requirements, and even assigning importance weights, it really shifts the paradigm, doesn't it?
It absolutely does.
So it's not just, is it generally good, but did it hit this, and this specific mark? Now, how much harder is it to actually create these specific weighted checklists compared to just setting a broad, helpful criterion? That seems like the tricky part.
That is where the clever engineering comes in. Crafting these effective checklists is itself an art, as you can imagine.
Right.
The researchers explored different generation methods. They found that just, prompting an LLM directly to make a checklist could sometimes lead to less objective criteria.
How so?
Well, the model might just sort of rephrase the prompt itself, which isn't always helpful for precise evaluation. You need something more atomic.
Got it. So it needs to break it down properly.
Exactly. This raises that important question. How do you get truly objective atomic requirements? Their more effective method turned out to be candidate-based.
Candidate-based.
Yeah. This involved first having models generate several responses candidates of varying quality to a given prompt.
Okay, like good ones and bad ones.
Right. Then they prompted a powerful separate teacher, LLM in this case, Qwen 2.572b instruct, to look at all those responses and identify all possible failure modes.
Failure modes. Like all the ways it could go wrong.
Precisely. And then they turn these failure modes into clear, simple yes-no checklist items.
Huh. So it's almost like it's learning what not to do, which is often a much clearer signal than trying to articulate every single thing it should do.
You've got it. That's a clever reframing, isn't it?
Yeah. Does this failure mode approach also help with those maybe trickier instructions where the intent itself might be slightly ambiguous?
That's an excellent point. And yes, it absolutely helps because it systematically covers the spectrum of possible shortcomings. It's less likely to miss something subtle.
Okay.
And to further safeguard against those more subtle reward hacking behaviors we talked about.
All right, the gaming.
Yeah, where a model might check off specific items but still miss the overall point of the instruction. They added a universal requirement to all checklists.
A universal requirement, like a standard rule.
Exactly. It's a brilliant bit of regularization, really. Acts as a guardrail. This universal requirement basically ensures the response, quote, directly addresses the request without excessive or off-topic information and matches the context and instruction regarding style like professionalism, friendliness, formality. So it keeps it focused and appropriate.
Yes, and always with a high importance weight, like 100, 100.
Smart. And to make all this possible at scale, they even built this massive data set called WildChecklists. You mentioned 130,000 instructions.
That's right, 130,000 instructions, each with its corresponding synthetically generated checklist and critically complete with verification programs where applicable.
Wow. That's a huge undertaking.
Indeed, that data set is really the engine that fuels this whole learning process.
Okay, so once these detailed blueprints, these checklists, are in place, the real question becomes, how does the AI actually use this super granular feedback to get better?
Right. That's where the sophisticated 4-step learning loop comes in. It's pretty neat.
Lay it on us.
Okay, first, the base language model generates candidate responses, usually 2 responses for each prompt it's given.
Step 1, generate options. Got it.
Step 2, flexible scoring. This is key. For each individual checklist item, 2 powerful tools come into play to grade the response. An AI judge.
Another LLM. Yes, another large language model like that Qwen 2.572b instruct again. And importantly, specialized verifier programs.
Verifier programs. That sounds incredibly precise, almost like running a piece of code. What's the advantage of that over just having another AI judge everything?
It's a really crucial distinction. LLMs, while brilliant with language, nuance, semantics, They can actually struggle sometimes with discrete, really explicit properties of text.
Like what?
Like, does the response contain the letter R exactly 3 times? Or does it include this specific keyword from the prompt? Things LLMs aren't naturally great at counting or enforcing perfectly every time.
Okay, I see. Hard facts versus fuzzy concepts.
Exactly. So if a requirement can be exactly verified with code, the system actually generates a little Python program for that specific item.
No way.
Yes. Its Boolean result, either 0 or 100, pass or fail, is then averaged with the AI judge's score for that same item.
Ah, hybrid approach.
It is. It combines the AI's nuanced semantic understanding for criteria like tone or intent with the cold, hard objectivity of code for verifiable facts. It's a really crucial insight of RLCF, I think.
Yeah, that sounds powerful. Balancing nuance and objectivity.
It tells us that for AI to truly get our complex requests, it needs a multifaceted feedback system, kind of like how we often evaluate complex human tasks, right?
Makes sense. And the AI judge part.
Right. The AI judge gives a score, say, between 0 and 100 for those more semantic or nuanced criteria. And this score is typically averaged over multiple evaluations, sometimes as many as 25 times per item, just to smooth out any random fluctuations, make it more stable and reliable.
25 times.
Yeah.
Wow. Okay, so bringing it all together.
Yeah.
We get this comprehensive weighted score for each response based on all the checklist items. Part code, part AI judgment.
That's the score. It's incredibly robust.
Okay, so what's the final step?
Right. Finally, for the actual preference tuning, telling the model which response was better, they don't just use every generated response pair.
No, why not?
They found it's more effective to only use the pairs with the biggest difference in these weighted checklist scores. Specifically, the top 40% with the greatest score gap.
Focusing on the clearest examples of good versus bad.
Exactly. This provides a strong, really clear learning signal. One response is definitively chosen over another because it followed the specific instructions much better. It just filters out the noise from pairs where the difference was maybe negligible or ambiguous.
Okay, that makes a lot of sense. Focus the training effort where it counts most. The proof then, as they say, is in the pudding. How well did this actually work?
The paper's results are, well, they're incredibly compelling. RLCF was the only method tested that consistently improved performance on all 5 of the widely studied benchmarks they use.
All 5. That's impressive. Which ones?
IFEVOL, InfoBench, FollowBench, LLMs, and Arena-Hard. Across the board improvement.
Wow. And we're talking significant improvements.
Yes, like a solid 4-point boost in hard satisfaction rate on FollowBench, a 6-point increase on InfoBench, and a 3-point rise in win rate on Arena-Hard. Those are genuinely meaningful gains in instruction following.
For you, the user, this isn't just some slight bump in abstract numbers. It means less frustration, fewer reprompts.
More reliable, useful outputs.
Yeah, exactly. It's a leap towards AI that truly gets your intent the first time.
And if we connect this back to the bigger picture, this consistency across diverse benchmarks is really RLCF's superpower.
Consistency is key.
Totally. Other leading reward models, the ones relying on those fixed general criteria, they showed really mixed results. They might improve on some benchmarks, but actually cause significant regressions, make things worse on others.
Oh, interesting. So fixing one thing broke another.
Sometimes, yeah. It really highlights how those general models can be too rigid, too blunt in instrument. They can sometimes even misguide the learning process, making the model worse in certain ways. RLCF's dynamic, tailored checklist approach seems to avoid that critical pitfall.
And the paper also found that RLCF particularly helped with content constraints, right? Those qualifiers in open-ended questions that limit the valid space of answers.
Yes, exactly. Things like list 5 examples but don't mention X or write in the style of Y. RLCF was particularly good at making the model obey those kinds of specific limitations.
Which suggests RLCF genuinely encourages models to pay attention to the entire instruction, not just the main topic.
That seems to be the case. It makes them far more obedient to our detailed requests.
What about the qualitative examples? Did they show specific cases where RLCF did better?
Oh yeah, and those are really illuminating. What stands out is just how much more stable and interpretable RLCF scoring seems to be.
Okay.
They showed an example where a standard AI judge might rate a perfect Spanish translation and an utterly incoherent one, like filled with phrases from various languages equally highly, just because its general rubric was maybe too broad, too focused on just, did it produce Spanish words?
Wow, okay.
Yeah.
That's not helpful.
Not at all. Or how some existing reward models can be overly sensitive to minor word choices, giving vastly different scores for responses that were semantically very, very similar. Just changing a few words tanks the score unfairly.
Right.
RLCF, because it combines that objective code verification for facts with a more structured, checklist-based AI judge for the nuanced stuff, seems to offer scores that truly reflect actual instruction following.
It balances the nuance of an AI with the unwavering objectivity of a program. That's the takeaway.
That's a great way to put it.
So, okay, this sounds like a phenomenal leap forward for instruction following. Really promising.
Yeah.
But I imagine all this detailed evaluation with multiple AI judge samples and these verifier programs, it's got to take a lot of computing power, right?
Yeah.
Is there a downside in terms of computational cost?
There is. You're absolutely right. That's the trade-off. There is a significant computational cost involved.
Significant.
Well, grading all those response pairs for the 130,000 instructions in their dataset using a large teacher model like Qwen 2.572b Instruct. It took approximately 4 days running on 8 powerful H100 GPUs.
4 days on 8 H100s. Okay, yeah, that's a substantial investment computationally, not something every lab or practitioner can just spin up easily.
Definitely not trivial. It's a serious consideration.
But did they find ways to maybe make it more efficient, to mitigate some of that cost and make it perhaps a bit more accessible?
Yes, thankfully they did explore that. They discovered that reducing the number of samples used for the AI judges score, for example, going down from 25 samples per item to just 5, could cut the total clock time by over 50%.
Oh, wow. Cut it in half.
More than half, yeah. And critically, with only a modest accuracy cost on most benchmarks.
Okay, so there's a dial you can turn.
Exactly. However, they did note that for the most difficult, most ambiguous constraints, having more samples did prove beneficial. So there's likely a trade-off between speed and ultimate robustness, especially for those really tricky instructions.
Makes sense. You might need more eyes on the harder problems.
Precisely. So while there's a clear computational investment needed upfront, the researchers are already finding practical ways to optimize it.
Good.
And looking ahead, this research opens up some fascinating avenues, doesn't it?
Mm-hmm.
Could we perhaps dynamically adjust the evaluation rigor based on how complex the instruction seems?
Ooh, adaptive evaluation.
Right. Or what about self-improving checklist generation? Could the system learn to make better checklists over time? The path isn't just about making RLCF work, but making it potentially universally accessible and maybe even smarter down the line.
So wrapping this up, what does this all mean for you, the listener, the learner, the innovator, the everyday user of AI? This deep dive into RLCF, I think, reveals that sometimes the most sophisticated problems in AI can be tackled with a surprisingly simple, structured approach.
It seems that way.
By breaking down these complex instructions into explicit, weighted checklist items, we can dramatically improve how language models understand and follow our commands. It's really about giving them a clear, unambiguous blueprint for success.
Like a well-structured project brief.
Yeah, exactly.
And it powerfully highlights the limitations of trying to guide AI with those broad, often fuzzy, undifferentiated reward signals. Instead, RLCF really shows the immense value of giving the AI a precise, multidimensional blueprint, not just a vague thumbs up or thumbs down.
Yeah.
This focused feedback loop seems to be what truly drives robust, reliable instruction following. It moves us closer to an AI that doesn't just generate plausible text, but genuinely executes our intentions.
And for you, the learner, this research really suggests a future where your interactions with AI could become much more fluid, much more precise. Imagine an LLM that truly understands your multi-layered requests, whether it's for academic research, creative projects, complex coding tasks, or just daily stuff. An AI that consistently delivers results that hit every specific mark you've laid out.
Less frustration, more genuine collaboration. That's the hope.
Definitely.
Which, raises a final important question for everyone to think about. If specifying instructions with objective, rated checklists makes LLMs so much better at following them, what other complex human cognitive tasks, things beyond just simple instructions, maybe intricate problem solving, or even creative writing with specific constraints could benefit from being checklistified in this way? How else can we use this structured approach to further bridge that persistent gap between complex human intent and AI execution? What new possibilities open up when the AI truly gets the assignment, not just broadly, but in every single precise detail?
That's a great thought to leave our listeners with. Food for thought.